We're going to solve one-step radical equations. And I have two examples here. And the first thing we want to do is move the constant term over here away from the radical. So I'm going to put a line right here. And I'm going to move away from the radical. So I'm going to highlight that. So the part that I want to get alone, I want to get this part alone. And I move things away from it, so I move it across the equal sign to move it away. So that's my goal, is to get things away from the part that I've highlighted. And the way that I do it is I either do the opposite operation, which would be that I would add this to both sides, or, and this is what I like to do because it's quick, I circle and move it and change the sign so I can get it to the other side, which is the same as adding it to both sides. This is going to leave me with the square root of x equals 7. Okay, well, when I have a radical, I want to be able to undo that radical in order to get my variable alone. So my goal now, I really want to get this x alone. And so I'm going to do that by doing the opposite operation. And my opposite operation, so opposite to the square root is, let's say the square root of x, is to take something like, just whatever this is and square it, right? The opposite is to square your square root. So I'm going to square both sides, because if I want to undo the radical, I have to square the left side, but what I do to one side, I have to do to the other side, because that's what equal signs mean. So I'm going to cancel that out because they're opposite operations and they undo each other. And this is going to leave me with an x on this side. And on this side, I'm going to get 7 times 7, because this power of 2 tells me I have the same thing multiplied twice. And this equals 49. Okay. Well, I need to check to see if my answer is true, because sometimes they don't work out well. Sometimes I do math and it feels like that's the answer, and it's not. So the way that I check it is I plug it back in for x. So I'm going to check it. I'm going to take the square root of x minus 3 equals 4, like I had at the very beginning. And I'm going to replace this x right here with 49. That's how I'm going to check it. So I'm going to plug that 49 back in. So I've got the square root, and I'll put that 49 in black, of 49. And then I will do my square root of 49 first, and that is going to give me 7 minus 3, and does that equal 4? And if it does, then I can say, yep, I checked it, and 49 works. So I know for sure that this is my answer. Okay, so I'm going to look at a different problem over here. And I'm going to do the same thing I did before. I'm going to say, well, I want to get this whole radical thing alone. I'm going to do that by moving this, I'm going to move this term right here to the other side. I'd either add it to both sides, plus 5, plus 5. Or I'm going to circle and move it, because that's what makes me comfortable. I'm going to circle and move it, and when I move it to the other side, it changes signs. Okay, so now this isn't here anymore. And I still have my square root of x, so I still have my square root of x, and negative 7 plus 5 is negative 2. And then I'm going to square both sides, and I'm going to square this side, I'm going to square this side. This undoes the radical, because there really is an index of 2 here. And on the other side, I get negative 2 times negative 2. Well, that is 4, because negative 2 times negative 2 is a positive 4. But I have to check my answer and make sure that that worked. So I'm going to say, well, I'm going to check it. So I start up here with the original equation and say, well, I had the square root of x minus 5 equals negative 7. Well, my original answer, we had this 4. So I'm going to take my x and I'm going to change this x to my 4. All right, so I have the square root and my minus 5 and my minus 7. I'm going to put my 4 back in. And when I take the square root of 4, I get 2. And that's 2 minus 5. And I'm asking the question, does that equal negative 7? Well, no. 2 minus 5 is negative 3. And negative 3 does not equal negative 7. So this is not an answer. So when I have this, I'm going to say that this is not, there's no real solution to this problem. Okay, so nope.